Hello everyone. In last session we have solved some examples based on sphere. Now in this session we are going to have my next example, that is find the center and radius of the circle of intersection of sphere and by the plane, right? That is what we are having here. One sphere is given to us. The sphere is intersected by some plane, right? And this intersection, now since we have seen the theory, we know that the intersection of sphere and the plane is nothing but circle. For this circle I need to figure out what must be the center and radius of the circle, right? So for this, from using the given equation of sphere, first of all I am going to figure out what must be the center and radius of the sphere. CQ will be radius. Then draw the perpendicular. Say P is my center of a circle and this length PQ is radius. So my aim is to figure out coordinates for P and length PQ, right? So firstly we are going to figure out what must be the coordinates for P. So to find out this, I'm going to figure out what must be the equation of CP. Okay, but before that I'm going to start with the equation of sphere, right? So what is given sphere? Given sphere is x square plus y square plus z square minus 2 times y minus 4 times z minus 11 is equal to 0. Now from this equation I can figure out what must be the center. Center is minus u minus v minus w. So since there is no coefficient of x, so u is 0. Coefficient of y divided by 2, so that is minus 1. Minus of minus, that is 1. Then coefficient of z divided by 2, which is minus 2, and minus of minus, that is just 2. And we also want to find out radius. Radius is here CQ, which is square root of u square plus v square plus w square minus d. So which is here 1 plus 4 and minus minus plus 11. So CQ is square root of 16, so that is just 4, right? So I got center and radius for the given sphere, right? The next thing I'm going to figure out, to find out the coordinates for P, I'm going to find out equation of CP. Now note that CP is the perpendicular drawn from this center C. So that means this is just a normal to the plane, right? So yeah, note that P is foot of the perpendicular drawn from C. So CP is normal to the plane. So since it is normal to the plane, direction ratios of CP are going to be coefficients of x, y, z in from the equation of plane, right? So therefore direction ratios of CP, these are equation for plane is given by x plus 2y plus 2z. So direction ratios are 1, 2, 2. And we want to find out radius of we want to find out equation of CP. So I need a point, and already I know CP is passing through 0, 1 and 2, right? So therefore what is the equation of CP? This is x minus 0 by 1, then by minus 2 by 2, and z minus 2 by 2. Now why we are finding this equation? Because using this equation I can figure out coordinates for any point which is lying on the line CP. So in particular I'll get the coordinates of P here, right? So I'll consider this is equal to K. So what is X? X is K, Y is 2K plus 2, and Z is again 2K plus 2. I'm sorry, this is 1, so this must be 1, and so this must be 2K plus 1, right? So now since this is any general point, so in particular I got P also. So what is P? K comma 2K plus 1 comma 2K plus 2, right? Now note that where is this point P? P lies on the plane. So since it lies on the plane, it should satisfy equation of plane, right? So that's how I'm going to figure out the value of K, right? So since P lies on the plane, x plus 2y plus 2z equal to 15. So it satisfies equation of plane, right? So just substitute this point in the equation and we'll try to figure out what must be the value of K, right? So I have here K plus 2 times 2K plus 1 plus 2 times 2K plus 2. This is equal to 15, right? So once I figure out this equation, using this equation I'm going to get this as 9K minus 9 is equal to 0. So therefore value of K is just 1. So since K is 1, what is the coordinates for P? P is, just substitute value of K here. So P is 1, 3 and 4, right? So this is nothing but center of circle, right? I got center of circle. Now using the center, the next part I need to figure out what must be the radius, right? So now note that here this is a right angle triangle. So to find out radius we can use Pythagoras theorem, right? So what will be PQ? PQ will be CQ square minus CP square. Already we know CQ is equal to 4. So just substitute the value, and CP you can find out using distance formula, since I know coordinates for C and I know coordinates for P. C coordinates are 0, 1, 2, and just now we found out coordinates for P, that is 1, 3 and 4. Just use the distance formula, right? So since triangle CPQ is right angle triangle, what do we have? We have here CQ square is equal to CP square plus PQ square, right? So therefore what is PQ square? CQ square minus CP square. CQ is 4, so this is 16 minus what is CP square? CP you need to find out using distance formula. So this is 0 minus 1 square plus 1 minus 3 square plus 2 minus 4 square. So 16 minus this is equal to 9, so just 7, right? So PQ square is 7. Since this is radius, the positive square root is 7, root 7, right? So therefore this is a radius of circle. I just use Pythagoras theorem here, and that's it.